All right, guys, welcome to Unit 2 review. I'm just going to try to limit this to less than 15 minutes. So here we go. First thing you want to do also that's not on this review to get ready for the test is to go over the first differences in 2.1. So there's a little video there going through the charts to figure out what linear is. So do that, please. Then we're going to look here in number 1. What's a monomial, binomial, trinomial, all these things here. So number of terms, right? 1, 2, or 3. The variables will be any letter that you see. So note here we have X's, then we have P's. We have A and B. So if there is more than one variable, please either put a comma or a space or an and sign or something like that. So we have A and B here. We have X and Y in this example. We have M and N are the different letters here. Coefficients are the numbers that go in front of the variable. So just be careful with the sign. So for example, this is -4. So this would be -4. A lot of people put +4 or they'll just put 4. You don't need to put +7 here, but if you want to put +7 for the first one instead of just 7, you can do that. Constants are numbers that don't have a variable associated with them. So here 10, here 1, here -3. If there's nothing else, just put a line through there. Don't leave it blank. But I prefer if you put a line through it. Okay, collecting like terms are terms like each other. What you want is the same letter to the same exponent. So for example, here we have P and P, that's good. We have X and X, but this is squared and this isn't, so that's not good. So unlike the last example, you have Z squared X cubed versus Z cubed X squared, so they're unlike there. So those are like and unlike terms. Simplifying, you're going to collect like terms. So if anything is a like term, then you collect them. So how many P's do I have? I add them together. Here I have a bunch of X's. I add those together. When I get to C, I have 3M and 5M. That's 8M. And then I have 7 and -2. Those are my constants. I add those together to get +5. So that's that. And you keep going. Let's look at E, for example. I have two different variables, S and P. So I'm just careful with the signs. I have 4S. I have -6S. That'll be -2S. So I circle these ones and I put squares around the P's. You can do that also if you like. You don't need to, though. So -9P plus P will give me -8P. And then how many constants do I have at the end? I have +5. So that's a 5 right there. Other things to look at. Order matters. Usually we put things in alphabetical order if there's more than one, but it doesn't really matter as far as that goes. When you have variables like x squared y and xy squared, in this case, don't collect them any further. They're not like terms. You can't do anything with these at this point. The order doesn't matter so much here. Where order does matter is where you have things like this, x cubed, x squared, and x. We put them in decreasing order. So we start with x cubed, then we go to x squared, then x, and then the constant would be last. That comes up later in grade 10 and in grade 11 when you start looking at what do these look like, the shape of these when we start graphing them. So it's preferred. It's not necessarily wrong. So if you had -36x squared first, that's fine. But if you could put them in order, it'd be ideal. Here, when you're doing the perimeter of the shape here, I put brackets here and then I add. So it's 3p minus 2 plus this plus that. The reason I do that is just to be careful that if you're adding. So for example, it didn't come up here, but let's say this was 3p plus, minus 3p plus 1. That the negative will go here, right? The negative will be here and not. It won't be minus 3p minus 1. It'd just be minus 3p. So you don't need these brackets, but if you have them, that's great. And then you collect the terms to get that, and then sub in 4 for p. So once it's been reduced here, take the 4 and put it into everywhere you see a lowercase p. So it's 9 times 4 plus 5, and that's 50, and that's a centimeters. They're a little cut off there, but that's your perimeter. Same with the next one, same sort of thing for the next one. Just be careful with this. If that's 3m, so is that. If that's m minus 2, so is that, right? This one's a tough one, I think. The perimeter here, solving for this. So what you're going to do, that's an S here. So I used S as my missing side here. So it looks a little like I5, but I put S here. So I said, this is the perimeter. These are the two sides. And then I'm going to solve for S. So I'm going to move everything over to the other side and solve for S, and S is 4x squared minus 13x plus 9, okay? So you can either move the x's over and the x squareds over all at once, or you can collect like terms on the right side and then bring them over after. It's up to you. So there's that. What else? Exponent laws here, okay? So when we multiply, we add the exponents. So 4 plus 7 is 11. This is going to be a subtraction because when you divide, you subtract. So 9 minus 3 is 6. Power of a power. So 5 to the power, you have a power of 5, all to the power of 5, you're going to multiply. So these are just basic here, right? So add, subtract, and then multiply. If you have many things to do, like these are being multiplied, right? So you're going to add plus 2, and then whenever there's not an exponent, remember that it's to the power of 1. So you can write the 1 there like I did there. So 3, 2, 1, 4, add up to 10. All right. Same with this. 1 there. How many A's do I have? I add those up. 3 and 2 is 5. 5 and 1 is 6. So that's how I get that. Now here, I'm going to clean up the top to get x to the 11, clean up the bottom to get x to the power of 8, and now I'm subtracting. You don't have to do it in the same order I'm doing it. This case, you probably would, but order doesn't matter really as long as you don't break any rules. So I'm going to add these up and get 11 and add multiply these to get 8, and then 11 subtract 8 is 3. Okay. This is going to be a power of a power here. So 6 times 3 is 18. Again, that's a 1. So that becomes 6. This one here, you're going to subtract each of these exponents. So for variable x, you're going to get x to the 0, y to the 3, and z to the 1 or or just z to the 1, but you can write the 1 or not. It's up to you. And then you're going to get rid of this, okay? So this turns into 1. You can put a 1 here if you want, or you can just have it kind of disappear. A coefficient of 1, we usually don't write. So that's what we do here. We want positive exponents only. So I'm going to show you what that means here. Here I go 7 subtract 10 is minus 3. So that's fine, except I asked for positive exponents only. So when you have a negative exponent, what you're going to do is put it in the bottom of the fraction. So a to the minus 3 is the same as 1 over a cubed. All right, here you subtract each of these, and they all turn out to be zeros, and you get 1. And here, up to you how you want to do this. You can go 2 minus 7 is minus 5, and then bring the a down to the bottom of this fraction. Or what you can kind of do is you can, if you would like to, this also works, is you can subtract the 2 on the bottom here. So 7 subtract 2 is 5, and write it down at the bottom. Up to you how you want to do that one, but either way, that's what you're going to get for your answer here. Here, when you multiply, just be careful when you add negatives. What you do, that you're adding a negative, you don't have the negative disappear. Very common for that to happen. So anyway, so you get g to the 4 because you add those, and h to the minus 3. But again, I don't want minus 3, so I want 3, but then I have to put it in the bottom of the fraction. These here, you're just going to get your calculator out and figure out the answers to these. So you just get roots. I mean, not to make life too difficult, but you can just go through it and go, is 5 to the 5, is this right? No. 5 to the 6, is that right? Yep. Okay. So just write that like that. So this is 5 squared. That's 5 to the 6. Anything, if it's 1, it's always going to be 0. That's a trick we tend to ask all the time. This is 1 over 5 to the 4 or 5 to the negative 4. Okay. So it's up to you. I'll take either here for that case. This one here, just be careful. You got to clean this up first. So you're going to multiply these across. 1 over 25 is 5 to the negative 2. You could also leave it as a fraction, like have this over 5, 2 on the bottom. Either way, you're going to get 1 plus 7, subtract 2, and 5 to the 6th. And then this one takes a bit of work. You get 5 squared to the power of 4. Okay, so this is 5 times 5, so 5 squared. So this thing, 25 to the 4, is equal to 5 to the 8. You could also expand 25 to the 4 and then work backwards to find out what that is. Okay, it's up to you how you want to do that. This one here is 125 is 5 cubed, and then you're going to square it, so that's 5 6. Okay, so figure out what this is, what these are as a base 5. And now I have 8 and I have 6, and then because I'm multiplying, I add those together. Evaluate each of these. So this is 1 over 4 squared, 1 over 16, 1 over 10 to the 1, which is 10. If you have a fraction, you can do this in 2 ways. The easiest way to do it is if you already have a fraction and you have a negative exponent, is just flip that fraction. So instead of 3 over 5 to the negative 2, it becomes 5 thirds squared, and then you square the top and you square the bottom. Okay, so it's 5 squared and 3 squared. Okay, same with this. You're going to flip this, 9 over 7 cubed, and then cube the top, cube the bottom, and anything to the 0 is 1. Why aren't these equal? Because the exponent here is on, I should have written more here, I guess. The exponent here is on 1. So this is equal to 1. This is equal, x to the 0 is 1, but then that's 4 times 1. So this left side is 4, right side is 1. Collecting like terms here to solve. Okay, so we're solving with an equation sign. So we want to bring everything over. You guys have done this before. So 6x, bring that 7 over, 6, subtract it, and then divide by 6 to get 9. Same thing here, same sort of thing here. Just be careful with your signs. Same with this one. I don't think there's much to it. This one here, there's a couple ways to do it. What I'm going to do here is subtract the 2. So I get 5 minus 2. So bring that 2 over, and I get t divided by 3 is 3. And then now this 3 is going to come across. It's dividing on the left, so it multiplies on the right. So t equals 9 now. That's the easiest way to do it, I would say. Over here, I have the 4 is dividing on this side, so it has to multiply on this side. The 3 is multiplying this side, so it has to divide when I bring it across. So then I kind of clean this up, and I go 9 times 4 divided by 3 is negative 12. Sorry, minus 9 times 4 divided by 3 is negative 12. So m plus 2 is equal to negative 12. So m is then going to be negative 14 when you bring the 2 across. Collect like terms to get minus 6y. Bring the 5 across to get 4. And then divide by negative 6. Just be careful that the negative doesn't disappear. Then you do your left side, right side check. So what you do is you just take your answer, your final answer, sub it in, and see if you get the same thing. So now if I have y minus negative 2/3, I'll just do this last one here. It's the hardest. Y equals negative 2/3. What you're going to do is sub in a negative 2/3 everywhere you see a y on the left side. So there I had 3y. So now it's 3 times negative 2/3 plus 5 minus 9y, which is minus 9 negative 2/3. And that's going to be, once you do the fraction work here, it's minus 2 plus 5 plus 6 equals 9. And the right side was 9 on that side. Okay, so there's the most difficult one. The interest questions they're not easy, but compound interest is interest on the interest. Their equations will be given to you just like this. So when you're trying to solve this, make sure you're doing simple interest when it says simple interest. 400 is the initial value, and you add 400 and you times it by R and T, and you get 400 plus 84, and that's $484. So make sure that you give me the answer either as a therefore statement, so therefore you pay this, or just make sure it's clear with a number dollar sign on it. This one here, you're going to solve for t, so it's a little more difficult. So you set it up like this, and then you subtract 80 from both sides to get 16. So now I have 80 times 0.4 t. You can do this one of two ways. One, you can multiply this times this, 80 times 0.04, and then divide it on the left, or you can divide each of these, which is what I did here. 16 divided by 80, let's just say 80, sorry guys, and 0.04. So this is on the bottom of the fraction. This is a little sloppier, so excuse that mess. But you could also multiply it on the left to get 3.2 and divide it that way. Go 16 divided by that, divided by 3.2. Either way, you get 5 years. This one is difficult. That's a 5. Sorry, guys, that's a 5. So you have this here, and I did this, what I did a little differently here. At 5,500, I'd probably do it this way. 5,500 equals 4,000 plus 4,000 times R times 5. 5 times 4,000 is 20,000. Subtract the 4,000 on the left, and then divide. Okay, so that's what I did there. Subtracted and then divided to get that. The interest rate ones are pretty straightforward. Just be careful that your n, quarterly means 4. Put the 4 there, put the 4 on top, and then it's just plug and play. You got to put everything in there. These ones are a little more difficult when you're doing a depreciation. You're losing 15% per year, which means you're retaining 8.5%, so that, or 0.85. So put that there, 0.85 to the power of 6, and figure that out that way. Why is the iPhone depreciate? Because it's old technology. And then these ones here, whenever you get a question like this, like 1.6 equals R to the 4, you have to hit the 4th root button. So find that on your calculator. It looks something like X root Y. And then you'll solve that way. If you can't get that, send me an email. I can help you with that. So that grows. I messed this up. That's B and that's A. This grows at 60%. It's just that divided by that. And then to find the rate per year, you take the 4th root. And the same sort of thing kind of happens in this last question for number 20. Okay, so check those out. If you have any issues with those, send me an email. I'm also going to be around on Tuesday for meets. So if you want to pop in Tuesday and ask some questions, feel free to do so. We can go over some of this stuff. But I'll be on Tuesday. And have a nice weekend and good luck studying, and see you soon.